Well, good evening, everyone. Welcome to our monthly meeting. So just a few announcements up front. First of all, a welcome to Adrian, who's a visitor. He's come all the way from Geeveston tonight, so well done, Adrian. Lucky door prizes. So if you haven't already filled in a ticket, please do so. And there are the prizes: a James Webb Telescope calendar and a Beaker Street beanie. But there'll be 3 prizes, so you can, if you don't want the calendar, you can go for a beanie. So just what's coming up tomorrow night: a continuation of our homeschool introduction to the night sky. So I think about 50.
No, 77.
Oh, only 77 tomorrow, so good.
Quick.
Yeah, we had a great night last night, and despite the cloudy skies, we could see the moon. The kids loved seeing the moon, and so did the parents, by the way. Now, Kelly's roadshow, where's Kelly?
Yep.
Kelly's roadshow continues up on the northwest coast, October the 2nd, so you'll be talking about activating communities in protecting dark skies.
Dark skies, yep, at University of Tasmania.
Yeah. So anyone online tonight from the northwest coast can make advantage of that. 17, 18, 19 of October, we've got Fonthill weekend. We were fully booked. There's been a cancellation today. I'm just going to assess numbers over the next couple of days. So if anyone missed out, then they can jump in. So there'll be an email about that during the week. We're assisting Dark Sky Tasmania with a couple of events in October as well. On the 19th, we'll be going to Wellington Springs to a night sky observing session. A couple of bus loads of visitors, 25 in each session. We can take on more volunteers for that event. If you're interested. And on the 21st, the Dark Sky Tasmania are hosting the National Dark Sky Australia Awards, I guess it is. Yeah. So we're once again taking some scopes down to St Albans at Taroona during the awards. So it's not a dinner, it'll be hors d'oeuvres and drinks during the evening. So apparently volunteers are able to avail themselves of these amenities. So there's that an incentive. October the 21st. So that's the same night, the Tuesday, we have our introductory workshops. Dallas would normally host that, but being a member of Dark Sky Tasmania, he'd like to be down there. So he's swapping out of that role for that night. Michael Booth is swapping in, and Michael will be talking about some beginners post-processing of images using Cyril Deep Sky Stacker and GIMP. So all freeware. So if anyone is interested in post-processing of their images, they can bring along their laptop and perhaps do some of that processing during the session. Otherwise, just observing what Michael will be demonstrating. October the 24th, a deadline for articles for the newsletter. I need some more images for the members gallery. I know it's been cloudy, but you may have got a few opportunities during the last month or so. October the 25th, a member observing and practical workshop at Mount Pleasant, and that will be preceded by a working bee, just to get the weeds back again. And October 28th, next monthly meeting, and Andrew Klokotchuk on sensing astronomical events from your backyard. So it sounds interesting, doesn't it? And at the end of October, the Night Sky Explorer. So we've got 31, I think 31 registered at the moment. So there's 9 spots still available. But tonight, we have Kelly Clitheroe, who is President of Dark Sky Victoria.
Yep.
And Director of the Geelong section of the
Yep.
ASV,
Yep.
Astronomical Society of Victoria. Just recently, a few of AST members had the great opportunity to attend VASTROC, which is ASV's biennial conference.
Oh, it's the Victorian Astronomical Convention, yeah. It's not just ASV, anyone can host it.
Okay, well,
Yeah.
that's good. Yeah.
Yeah.
So in this case, Kelly was the
Yeah.
host, and I'm sure it was a lot of work, but it was one day packed full of very interesting talks, and the Tasmanian contingent were made very welcome. So, really nice experience for us all. So tonight, Kelly will be talking about citizen science and education for amateur astronomy. So, certainly it's a part of the hobby I never really thought existed, but when I joined this citizen science or education, public education and awareness. So I think it's a terrific part of what we do. And not, when you look at a lot of societies, it doesn't happen that much. They're mainly sort of inward looking at their own activities, but this is very much outward focused as well as looking after our own interests and what we love doing. So I'd like you to make Kelly very welcome to our meeting tonight.
Thank
Kelly.
you. I've been told I don't actually have a mic that works for you guys, so I'm just going to have to use my teacher voice. I am actually a member of the Astronomical Society of Tasmania as well, so I am one of you, which is very good. So I've been teaching at a regional school in just outside of Geelong for the last 30 years. And when I took up the job as Section Director at Geelong, one of the things that we took on board was a lot of scout groups. And there weren't terribly many activities. And so unfortunately, we do have cloudy skies. And not all the time you can't take the kids outside and look at the skies and things like that. So we had to come up with some other activities. And then this rolled over into a group that I was running at lunchtime with my year 7 and 8 students. One of them actually did the design that you can see there. Part of my role at school is I also am a primary school liaison. So that means that I go out and I run STEM programs with, we have 13 schools that feed into my secondary school. And I go and do STEM work with those students as well. So I run extension maths programs, science programs and so on. So I'm often bringing solar scopes and things like that into the classroom. And I ran a term-long astronomy group at one of my primary schools, which was very, very well received. We did a lot of citizen science stuff with that. And I'm going to be moving across. This is what the back of my car looks like. This is a real photo. I didn't doctor this. It just happened to be, I looked at it and I went, oh my God. In here, I carry around my C-Star. There's eyepieces, all sorts of things in there. I have a work C-Star and I have a home C-Star. The work C-Star is very, very frequently out in the schoolyard at my school. I take an image of the sun as often as I possibly can. And then when I take it into primary schools, they really enjoy looking at it as well. So this is Drysdale Primary School. This is my school here. Going out using the solar scopes. It's when you've got the really, really teeny weeny little ones and you've got to actually physically pick the child up and sit it on the chair. And this little darling here was a little preppy. And I said, okay, can you look through the eyepiece and close one eye and put your hand over the other one? She's gone like this. And so you kind of got to work around some of the difficult things that these little ones bring. This is Clifton Springs Primary School. So this is the school that I was running the astronomy program at. And again, just some, these ones were little grade ones. And they were enjoying the whole idea of looking at the sun. I'm going to just stand here and just flick this for a moment. This is my school. So we've had sausage sizzles and, what we call mufti days, casual dress days. Whenever we have one of those, I always have a solar scope out. So I've got the Coronado and we do hydrogen alpha viewing. And then I've got the C-Star as well. And the kids can look at it. They feel very comfortable with the C-Star. It's very accessible. They understand the whole notion. They're zooming in on the sun and they're looking at the sunspots. And it's not intimidating. A lot of them still feel funny about looking at the sun. Oh no, we've been told we're not allowed to look at the sun. And so there's a lot of reluctance there, even with adults. For any of you who use solar scopes, there are still adults who feel quite intimidated by the whole idea of it. This is Clifton Springs Primary School. So I ran a series of activities with these kids once a fortnight. And this particular activity, we were looking at the sun, and we were measuring the sunspots, and we were calculating the rotational speed of the sun, but I'll talk a little bit about that in a second. So with the sea star, the kids were all given images or what was the sun that we were looking at today. We expected them to draw the sunspots. There's a lost art to astronomical drawing. Not many people do that anymore, and it's something that I would really like my students to take on board again. Then we go look up the space weather live, and we look at it, and then the kids have to classify what the sunspots are. There's a couple more of the kids' drawings. Very obviously not mine with terrible writing. We then tie this into Zooniverse. So this is the citizen science part of this. So I'll talk about Zooniverse a little bit later on. So this one here has an activity where they have historical images of the sun, hand-drawn images of the sun, and they want citizen scientists to look at these hand-drawn images and identify how many sunspots there are, and they're looking at the movement of those sunspots over time. So once we've done the first activity, the kids are looking at the sun, they're drawing it, they're identifying it, they know what they're supposed to be looking for, then we're counting it, then we get onto the citizen science, and then they can actually do those activities as well. They've all got accounts, it's free, but like I said, I'll talk about Zooniverse in just a second. Now, I like using the sea star. It gives you, when you print up those images, it gives you an A4 page, and it takes up a nice proportion. It's about 15.4 centimetres, the image that you get off it. They're repeatable, so every single day I know that I can take a photo of the sun and it's going to look exactly the same, apart from the sunspots, as the photo that I took the day before. There's no zooming in, there's no alterations about it. Generally the photos are pretty much the same colour, and because it's so repeatable, that makes for good science. Being able to repeat something is good science. So the kids have got images like this. I've been tracking a particular sunspot, so it actually started over here and then has been moving around. These were tracked over a couple of days. I think it's obviously 4 days. The students then had to look at our dinky wooden rulers. Yep. I've had these rulers for I don't know how long, and my kids every year I have repeated like students and their older siblings and their younger siblings and so forth, and they all write their name and they write their date on them. So the rulers are quite useless as rulers. So what the students had to do was to measure the diameter of the sun, and then we had to fill in this activity sheet here. So the diameter of the sun is 1,392,700 kilometres. Then we had to bring it down to I think it's about 15.4 centimetres. I think we were actually working in millimetres because that made more sense. And then they had to work it out here. So this is the activity. If anyone actually wants this activity, I'm more than happy to provide that for you, particularly if you've got kids who are doing homeschooling. This might be an activity that is something that they can do at home. So how much bigger is the sun than the earth? So they had to work it out. So we know the diameter is this big. They should be about 109. Using a ruler, measure the diameter of the sun. Using one of the solar images, convert the sun's diameter to the scale. Here we are, and then whatever your answer was up there. So using the ruler, how many kilometres does each millimetre represent? How many millimetres would this be? And then there's some hints on it. We ended up getting, down here, 1.07 kilometres per second. Now, I think that the real rate is 1.98 kilometres per second, so we were in the correct order of magnitude, and that doesn't take into account that we're using a linear image versus a spherical image. It also doesn't take into account the fact that at different points on the sun, it rotates at a different speed. So, yes? This one here was year 8 students. Year 8 students, yeah, so 13, 14-year-olds, yep. Yeah, I have done it with younger ones, but it was very, very, very supple, like it was very scaffolded, yep. It is. I do that with the moon though, more than the sun, because there's more of a distinction between the sizes of the moons. Yes, so it's very, very small, whereas I did do an activity where we looked at a supermoon versus a standard moon, and you can actually see the difference in sizes. So yes, all those things are, and you can absolutely see the difference with the sea star in those images. We make sundials. These are heaps of fun for the kids to do. This one's here a really nice, simple one. This particular, again, if anyone ever wants any of these printables, I'm more than happy to share it. This one here isn't mine, so I'm happy to share it with you. I don't know where, I think I got it from the Museums Victoria website. One of the other things that we did was made pinhole cameras. So we put a piece of film in, and then this one here is the downball courts. So you can actually see the downball courts here at the school. And then we tracked the sun over 6 months. So this is showing the movement of the sun over that 6-month period. Some of the kids took these home and did them at home, which was terrific. All of them got an image, which was even better. And my can actually got very, very wet. And it was covered in spiders and things like that. But, you know, that's half the fun of it really, isn't it? Has anyone ever done this activity, by the way? No? It's a really easy, you'd need to do it between the solstices. And basically you just get yourself a regular can. I used a can of, I think this one here was a can of Mother or a can of Monster that my son had finished with. You just poke a very, very tiny little hole in it. You put a piece of black and white paper in it, tape it all up, and then just leave it somewhere, obviously facing north. And there's a guy that I follow, Gianluca B, starts with a B, and he does some amazing images around Italy, and that's kind of what inspired me to do it. And the kids loved it. They forgot all about it until I said, hey guys, we need to take it off. We've been doing, this one here is actually a NASA activity, and we're looking at density and speed of solar winds and, you know, the pressure, the ram pressure of, this one here I did with my advanced maths class. This is not one that I would recommend for everyone, but it was an activity that I had done. So we were talking before about the moon. Now, the kids were, in this particular activity here, we had images from the 1960s of the moon, and then we were comparing the images that we'd taken recently and looking at the differences in craters and so forth. So where is the moon different from the 1960s? What is causing all of these and so forth? The kids had to identify different things on the moon as well. We talk about moon phases because we can take photographs of the moon even during the day, and particularly during the day while we're at school. Otherwise, I have to take all of those images. So just using the sea star for this sort of thing, we can easily show why we're having a look at phases of the moon. You know, it's all very well and good for the kids to look at it and go, oh yeah, it's quarter, it's crescent. But why is it important for us? And obviously that is because we can identify different things, because the contrasts are different. I've now expanded this activity a little bit further. I don't know if it's in this one. So these are all the photographs, and they had to identify the different craters. So again, it's using real data that they can see in front of them to be able to identify different things on the moon. I try really hard not to get kids' faces, so this is all of them doing the work here. We made a lunar calendar. This is an awesome one. You get this off the JPL website, the Jet Propulsion Laboratory website, and that's a really nice little one. And this is one that I just did very, very, very recently, and we're measuring the crater depth on the moon, of different craters on the moon. So again, a sea star image. I had to find something that was around about the same diameter to make the circle. So we know that the moon's diameter is 3,474 kilometres. We had to measure the shadow. We do the shadow times whatever the ratio is, then multiply it by tan of the angle of the sun. I had to look up the angle of the sun for the kids. And I got the crater here, and this, I'm trying to think what the name of the crater, the Walter crater. I measured it out at 3.95 kilometres. The actual crater is 4.1 kilometres. So we got it, you know, reasonably accurately. So again, a nice little activity to do with kids. It's easy enough. I give them the formulas. I tell them the sun's angle, and all they've got to do is plug that into a calculator. And they have to be able to identify the craters as well. So that's part of the activity, is which crater you're going to be looking at. okay, let's do some research and actually find out what the depth of those craters are. So it's quite a rich activity. We did make an astrolabe. Haven't used it. It's a Northern Hemisphere one, so you know, but it's a beautiful thing. I'd love a brass one for the Southern Hemisphere. Now this is an activity that I did actually bring in today. This is one I do with my scout groups and my little cubs when they come in. So what we get them to do is they choose a constellation that they like. In this case, I just found some images off the web. They cut them out. They stick them to the bottom of their cup. They use a pin and using the phone. Don't know if anyone can see this. Can we have lights off, or is there a way for me to? Straight up on the ceiling. I don't know if it's going to work. No, it's too far away. Oh, there we go. Beautiful. So we've got Scorpius. All right. It's just because it was nice and obvious. Thanks, Lisa. And this is a really, really nice activity. You can give the kids the little cutout, or you can ask them to go and find an image using their computers or their devices, whatever it is, and then they have to translate that. So my little cubs really like this. It's not too difficult for them to be able to do this. That looks almost the same. It's not. I did this one in the B&B this afternoon. Now, you've all probably done a solar system walk with the kids. Yep. All right. So I do this one here with stepping, and particularly when I've got really, really active scouts who get really, really bouncy and fidgety. So usually I've got, you've got your son. You have one kid who's usually the kid who doesn't want to run around. They get to hold the sun. So we walk 4 steps from the sun, 7 steps from the sun, 10 steps from the sun, and eventually there's a kid, who's 300 steps away from the sun. Nice and easy. Now, if it's awful and rainy weather, that's when you get your toilet paper out. The toilet paper model. Yes. It's fun, isn't it? This one here was supposed to be about me. So where's Uranus? All right, so this is where we start with the kids. Where's Uranus? Okay, it's about halfway, yeah? Right. So we fold our little piece of paper in half. There we go. Some people are folders, some people are scrunchers, but we are a folder today, and we're going to draw Uranus. Of course, the kids are cacking themselves by now. I work with a lot of teenage boys. All right, tell me some facts about Uranus. What do we know about Uranus? So you can't even stop yourselves. Tell me some facts about, what do we know about Uranus? It's a gas giant, yes, okay. It is a big gas giant. Ask my 19-year-old son. Okay, tell me something else about Uranus. 84-year orbit. Okay, so I'm going to write that down. So it's an 84. So this is a really good activity to get the kids, because the kids all know facts about the planets, and particularly scouts. How many? Earth diameters. All right. I don't know that off the top of my head. Does Uranus have a ring around it? Yes, it does. It does have a ring around it, but what else is special about Uranus? Yes. And there's something that's different from to it. It's lying on its side. So Uranus is on its side. Yes, so it's completely different from all the other planets. So the kids are actually doing this while you're talking, by the way. Everyone gets a piece of paper. All right. Now we're going to fold our piece of paper to Uranus. And what's going to go here? Neptune. All right, tell me some facts about Neptune. Is it as big as Uranus? Come on, let's grow up a little bit. Is it? It's about the same size? All right, so it's about the same size. It's also gassy. Not quite as gassy as Uranus, but it's still gas. All right, and then and it is blue, and what's going to be up this end here? So if we're working up this way, what will be up this end? So the Kuiper belt? Yep, so we can call that the Kuiper belt. All right, so we're going to put Pluto in there. We'll put Makey in there. We'll put, whoever, whatever. The kids knows the planet names, okay? So they'll give all of that information to you. All right, so let's go back to Uranus. All right, now what we're going to do is we're going to fold our little piece of paper in half again. All right, what goes between Uranus and the other end? Saturn. Very good. All right, so Saturn's a bit bigger. What do we know about Saturn? Yeah, lots and lots of moons. And the kids love to tell you how many moons. I don't know how many. I think some kid told me the other day it's like 250 moons. Yep.
It's a gas giant.
Another gas giant.
29-year orbit.
Now, also tell me, how wide are those rings? How thick are they?
Across the. Oh, you mean, sorry.
Yeah, how thick are they?
They used to be 10, but they're not. They're only about a kilometre. I used to think they were about 10.
Yep. So last time I learned anything about it was about 100 metres. They're really, really very, very thin. All right, about 100 metres. Anyway, so that's Saturn. So the kids are doing this as we're talking, and they're giving you all this information. All right, we're going to fold it in half again. What are we going to get next time? Jupiter. Tell me some facts about Jupiter. It's huge. It's the biggest planet. Big red spot. Okay, so the kids are drawing their big red spot. It's got lines on it. It's got poles on it. It has auroras, does all of those sorts of things. We're going to fold it in half again. What's going to go here? No. The asteroid belt. So we're going to draw little asteroids in here, and we're also going to draw Ceres, because Ceres is a very, very important big asteroid in here. So we're going to include Ceres. Some of the kids might actually know that. Fold it in half again. Now we're going to go to Mars. Okay, so we're going to put our Mars just here, fold it in half again. We're going to get to Earth, fold it in half again. Venus, good, oh good, the crowd's working. And fold it in half again. Mercury. Okay, by this stage, the kids are usually panicking because they feel like they're running out of room. I used to have this so that they would write the sun on the bottom of it, but they'd always do the sun too big. So it's actually better just to not even include the sun. And then we turn it round, okay, you're the sun, okay, and then we keep going out across the solar system, okay, so it's a nice way to do this. All right, so it's a good way to use up toilet paper as well. The little kids really like this one. This is something else I do with my students at school, so I've got my trundle wheel and chalk, and we go out and we actually measure things out as well, which is lots and lots of fun. We talk a little bit about stellarium. Okay, here's an activity. Volunteer from the audience. Can I have a volunteer? A volunteer. You volunteered. Come on up here. Look at you. All right. There you go. There's the moon. Here's the Earth. Here's the moon. It's actually approximately around about to scale. We can fit 4 moons across the Earth. Okay. Can you verify that that is around about the right proportions? Around about. Very good. Okay. Can you please tell me, if I stand here nice and still, which is very difficult for me, can you please tell me how far away the moon is from the Earth? Oh, on average, 382,000 on average. This is 12,000 kilometres in diameter. It is 40,000 kilometres all the way around in circumference. So you tell me where you want to be. Go on, keep going. Come on. Oh, you reckon you're about there? All right, okay, you stand there. Up you come, you. Yes, come on, up you come, Richard. All right, wrap your arms around that, okay? All right, now you're going to stand next to me and you're going to do one arm length out here. So there you go, out. Up next, Stefan. Go stand next to him. I'm going to need a few more. Lisa, you come up next. Now you're going to put your arms out, like right out, because this was the circumference. All right, so Lisa. Yep, next. Yep, next. Good, next. You do this with... Yeah, you're going to do 10 of them. Well done. So how many more are we going to do? So we've got 1, 2, 3, 4, 5, 6. We need a few more. We got 7. We got 8. Ross, you guess there? And you've got to keep going a little bit more. Now, this is a terrific activity to do with kids because the majority of the time you ask a kid, where is the moon? They're going to stand maybe here, okay? But to actually get them to physically stand up, wrap their arms around it, we get them all lined up like this, it becomes a very powerful thing. Thank you all my lovely assistants, well done. Now, if you've got a bunch of unwilling kids, which sometimes does happen, by the way, the other thing that you can do is you can wrap your earth around 10 times with a piece of string and then stick it onto the moon and then get the kids to run around, and it does exactly the same thing. But I always ask the kids, first of all, can you please tell me how far away you actually think the moon is, okay? And then they're always just so shocked. If I was going to do the sun at the same measurement, it would be 3,000 times further away. So again, we're talking about scales. So, but for school groups, for scout groups, fantastic activity, just talking about distances and getting that concept of spatial distances. Now, we used, you guys will all use Stellarium, yes, when you've got scout groups and things like that as well. So it accurately displays the night sky from anywhere in the world. It includes 20 pre-installed sky cultures. I was at a conference recently, a symposium week-long, and there was a number of people from the Ainu, who are the Japanese up the very top of Japan, above Hokkaido, and they've got very, very well-documented star lore. So I think that after this conference, there's going to be even more sky cultures put on, which is going to be very good. And so you can basically give it meaning. Unfortunately, the Australian sky lore is lacking significantly. Probably the best documented sky lore is that of the Burong culture, and that was because a pastoralist named William Stanbridge actually went to the people and he documented it. But most other cultures don't really have, and we've got 300 language groups, and very, very few of it has ever been documented. So that does make it very difficult. So if again, and I'm like I said, this majority of this is for rainy days and things where you can't get the kids outside. So you're going to watch the little video called Emu in the Sky. We start up Stellarium. We set the date to March. And the reason that we start at March is because the emu in the sky tells the story of the movement of the emu and going hunting for eggs. So when at the beginning of March, the emu is pretty much standing upright up here, and that's the time that they're mating. Come around by June, the emu is sort of laying down a little bit. This is where he's sitting on the eggs. That's when you know you can go hunting for the eggs. Always leave a couple of eggs in the nest. By the time we get around to September, the emu is now dipping down this way in the sky, and we know that the eggs are hatching, and you don't go hunting for the eggs because there's babies in them. So what does the emu look like in April, in June and August? Discuss how this signals the behaviour pattern of the terrestrial emu. So it's bringing that idea of culture and the reasons why other cultures had meanings for all of the stars. And it's very easy to be arrogant and think that the only knowledge that we have of the skies is that of European knowledge. And the Chinese have got fantastic sky culture. As I said, the Ainu people of Japan have fantastic sky culture. The Maori people have brilliant sky culture. Okay, they have a whole day off. There's a public holiday because of Matariki, which is the first time that they see the Pleiades in the sky straight after the winter solstice. Yes, and generally feminine. Their Orion tends to be masculine. Yeah, so it tends to be very masculine in a lot of cultures, and the Pleiades always seems to be feminine. So this is Zooniverse. So I like Zooniverse. I do a lot of stuff with Zooniverse. And I would encourage anyone, and this is people who are watching from home, particularly if they are, we talked to a couple of families yesterday about the homeschooling. This is brilliant for getting kids involved in some of those activities. So I use, so this is Radio Galaxy. This is using real data. This is using data from NASA, it's using data from ESO, it's using data from all around. It's terrific. So basically what it is, they give you a little training program. They say, this is what you're supposed to be looking for. Now you go off and do it. So you don't have to worry about it. My favourite one is Einstein at Home, and this one is looking at pulsars. Kids love this. I had kids that I taught that day. They went home and they did it for homework. I didn't even ask them to. And they said, oh, Miss, we've been finding all of these. It's been brilliant. So what they do is they say, okay, this is a really good candidate for a pulsar. It's got very, very obvious blips. You've got some horizontal, some vertical banding, and then you've got a reasonably smooth sort of bell curve. So you go, okay, that one's not a bad candidate. This one here, it's all over the place. There's no clear and definite blips. You can't really see any vertical banding here, although there is a reasonable sort of a bell curve. The rest of the data would suggest that this one here is not a good candidate as a pulsar. So the whole thing is quite easy. Yes. So this one here is Galaxy Zoo. I think Galaxy Zoo has actually finished now. Now the lovely thing about this is if you make some contributions to Zooniverse and it gets verified by any number of other people and then they go, okay, well, yes, everyone else has agreed that yes, this is a pulsar or yes, this is a galaxy, you actually get named in it. So when they write up the paper based around whatever it is that they're trying to find, your name actually appears as one of the contributors, which is really, really cute. So that's my name just there on whatever it was I discovered there. So again, same thing. They give you a little image. They say, is it smooth? Has it got features or a disk? Are there any stars? Are there any artifacts? You have to just answer the questions. It's pretty easy. I am going to go out of here for a second. That was my knees. And all right. So this is Zooniverse. So very, very easy. You just sign up. There's me. I've signed up the top there. You go across here to projects and you go down and you say, okay, I'm interested in. Now, it isn't just astronomy. It isn't just science. There's a whole thing on literacy and books. And one of them is analysing pictures from picture books. But let's go and do astronomy ones. Space, there we go. All right, these are all the different activities that you can take part in as part of citizen science. So we can look at supernovas, we can look at stellar stream identifications, cosmic collisions, extra asteroids, radio galaxies. This is one I was telling about before, sunspot detectives, exploring historical solar drawings to understand our sun's changes. The Einstein at Home pulsar seekers. So let's have a look at this one, because this is one of my favourite ones. Pardon? Yes. Yeah. So, but there's so many different activities that you can get involved in. All right. So let's go. Right. So we've got training mode and we've got expert mode. So when you're only learning, stay on training mode. Once you get to expert mode, so they say, okay, this is a good one. This is not a bad one. All of these here, and they're saying that these are actually quite okay. So you can also see that it's 95% complete, so they do have a time limit on their different activities as well. All right, go back to projects. We'll go back to the science ones. But in terms of your citizen science stuff, this is really cool, and you are actually contributing to some of these things. So we've got the black hole hunters, cloud spotting on Mars. The Aurora Zoo is quite good and it's probably something that you guys could get involved in. The Galaxy Zoo, backyard worlds and so forth. So that is Zooniverse. Anyone who is watching from home, I really do encourage you to get on board with that. Oh, whoops, I've done the wrong thing, hang on. Let's go down this way. Done that. Sorry about this. And I think I was here from the current slide. There we go. Now I think I've got it right. Okay, so anyone in here do variable stars? Yeah, quite a few people do variable stars. So this one here is classifying the light curves of variable stars and finding some unusual ones. So anyone who might be interested in that particular one. This is a really cute one for little kids to do. It's you go to mygalaxies.co.uk and it writes your names in real galaxies. And the kids can print it out, take it home with them. So a nice fun activity. Might be a nice thing to do at Beaker Street and just have something where they print it out straight away and they can take it home. This one here is chromoscope.net, and you can actually look at our Milky Way. Gamma ray, X-rays, visible rays, hydrogen alpha, near infrared, and so forth. This is really incredible to have a look at for the kids. We do ISS, the ISS Transit Finder. So if we can ever find an instance where we're going to get the ISS going across the face of the sun or the moon. I do a lot of stuff with Indigenous cultures. I'm quite passionate about Indigenous cultures. Again, I was talking before about the Burong people. This is a terrific website and has lots and lots of information. You have the Palawa people, is that correct? Yes. Is there much documentation of star law? No one's really looked? Yeah, a little bit, but yeah, okay. I've run activities, debates with my students. Literacy is a really big thing at my school at the moment. So space exploration is a waste of money. And I said to the kids, you guys are for it, you guys are against it. Too bad if you believe the other way, because it's, you know, and yet you weren't allowed to say just because it's not fair. So we think it's a waste of money. It gives us no direct benefits. It's not fully explored yet. Commercial space industry is taking over. Finish your priorities. Money's better used to help humans in their own countries. Many discoveries have been made as a result of space exploration. It's our nature to explore things. Scientific knowledge has value beyond the measurements. So I don't know what these are genuine things that the kids have said. Wow. If you want this, and this is one of the things I offered you, Lisa, as well. If you guys, this is what I run for Scouts Victoria. I have a Cubs, a Scouts, and a Girl Guides one as well. So for the Cubs, it's learning the meaning of the term astronomy, solar system, equator. So we scale out the solar system. We explain how the moon affects the tides and compare what you can see through a telescope. For the Scouts, what do you know about the night sky? Why do the stars change? We learn about astronomy, celestial bodies, equators, poles, ecliptics. We have to find south, so that's one of the big things with the Scouts is they have to find south. Observe 3 constellations and read a star map, and that could be a star map on the phone or it could be a planisphere, and learn how to identify a satellite. This was a symposium I went to last year or the year before, and one of the things that they do is they host, it's called Our Solar Siblings. And what it is kids actually get a login password and they can use any number of telescopes anywhere around the world. So even during the day, they can go and log into one in the Northern Hemisphere. They go and find objects, they can image those objects, which is something that we can't do here in the classroom. And it's one of the things that I found very restrictive is when I'm trying to teach astronomy, I can't actually take the kids outside and we can't look at things. But using this type of thing here, if anyone is interested, I'm more than happy to give you the person who's in charge of the program, and you guys can get kids working on this sort of stuff. In Victoria, we have the VSEC, and they have a 3-metre radio telescope. The biggest problem with this, though, is only one kid can operate it at one time. So it's, although I can operate it and show the kids how to use it, it's not much use in the classroom setting because, you know, only one kid can ever do anything. And this is me. And that's it. Does anyone have any questions? Hello.
Yeah, look, I was wondering, often about public nights.
Yep.
We often try and find things that are not seen, like globular clusters, not just the planets.
Yep.
And we can look in a planet and they can see a planet. Is there some approach to try and explain what a globular cluster is, or galaxies even, if we have the, but we often can't see those because we need the moon for safety, you know, people running around at night, they have some visibility then when we are dark.
Yep. So are you saying that you actually want to be able to explain what a
well, we're trying to sort of, all they see is this blobby, fuzzy ball of,
yeah.
I mean, it's very hard to explain to, say, a grade 1.
Yeah.
But an older person...
I think the only thing you can do is prepare them and say, tonight, because it's clear, we're going to be looking at, and this is what you're going to see. And you can have some pre-prepared images. I know that, Lisa, since you've got your little screen up, you can actually display images that you've taken on the screen, and that will help enormously, because then you can actually just say, well, this is an example of a globular
So
cluster.
we have to sort of look at a point of view of, like a group, if you like. One person has a C star, or
Oh, I mean, Lisa's just got her images. She can
yeah,
even-
I mean that's
yeah.
what I mean, and then work together as to say, okay, it is partly because it's pretty hard because of the weather situation.
Yeah.
You know, you can't look here because a cloud there or whatever.
So I've just got a little projector.
Yeah, well, we may have to have a look at that because it's so hard to explain to them. Here's an area of stars with 100,000 stars.
They're all in a clump
Yeah,
together.
clump
They're all around
together.
about the same age. They're all, you know,
Yeah.
the same type, all of those sorts of things. Yeah. So, and unless you actually have an image that the kids can see, sometimes all they're looking at is just a fuzzy thing. And you know, at least here you've got reasonably dark skies. Where I'm in Geelong, it's very, very to even look at Tuck. It's just like Tuck 47. It's just fuzz. Yeah. Yeah, it's quite difficult. Yeah. But I agree, but having the ability nowadays to be able to cast an image onto a wall means that then you can say, well, this is what you're going to be looking at, or this. We're going to be having a look at a number of different objects tonight. One of them is going to be the jewel box. One of them is going to be a cluster. One of them is going to be. Yeah.
It's very hard to coordinate because of the weather conditions and.
Yeah. Yeah, that's right. Yeah, and that's right. Yeah, well, we were all looking at the moon last night, so you know, I think every single scope had the moon looking at it.
But the good thing that I found with Beaver Street was when I had my sea star out. Oh, sorry. Thanks, Ross. When I had my sea star out, and then the other guys had your particular telescopes out, I'd say, go and have a look through the telescope and see whatever they happen to be looking at, and then come to me and I'll show you it through the sea star. And then I would explain the difference between the two different, types of viewing.
Yeah.
And they could see the difference in of what digital as opposed to optical, and so on. Yeah. So that worked quite well.
Yeah. There is. I mean, those little sea stars are terrific for outreach. I mean, for the price of them and all the rest of it. I know that there's a lot of purists out there who say, oh no, but they really are brilliant for what they are. There's a lot of work being. I was saying the other night that I actually want to put together a little document. I do a lot of spectroscopy with my sea star, but you can do astrometry, you can do photometry, you can do lots and lots of things with them. It's just, in fact, the variable star group has an entire page now dedicated to how you can break down a sea star image so that you can measure variable stars, pulling out the green channel, all of those sorts of things. So they are recognising that because so many people have them, that they need to be able to get that information from them. And you've got a whole bunch of new people who are now astronomers who can contribute to science. Yes?
Early on, you mentioned that in setting out, there wasn't much activity with scouts and cubs and that in the Geelong area when you
Well, there
started.
was. It's just that it wasn't very organised.
Well, that was going to be my question about it. What did you go through to get it organised the way you sound?
Well, because I'm a school teacher. And so for me, I got in contact with Scouting Victoria, and I said, what is it that you guys need to be able to do for this? Why do the kids want to come out to an astronomical society? And they said, well, they want to be able to find south. They have a navigation badge. There's also the older kids have a personal interest community badge. So it fits under a number of those different categories. The Girl Guides, when I spoke to them, they're interested in the creativity, the science of it all, and so forth. So it was trying to get a program that was going to work for everyone. And so I always had to have something where there was some information, some factual information that the kids had to get. There was always going outside and viewing, and then there was always an activity. And in the case of sometimes, the weather was inclement, I might have 2 activities for them. But they had to be different activities because I often had them as cubs, and then they'd come back to me as scouts. And so I had to make sure that whatever activity I was doing wasn't repeated, because we did this last time, so, which is what I get a fair bit. But the other thing is, because we've now, with the ASV, we've got regional sections in Mildura, Shepparton, Hamilton, Wimmera, Bendigo and Geelong. We also all needed to be giving the same information, because it's no use, Shepparton giving different information from what Geelong's giving. If we're working as a group, then we need to be giving the same information. And the idea with us being regional sections is that every young person has access to the same information and the same experiences. And so that was, as much as anything, my push to get something that was easy enough to follow for anyone. Yep. Dallas.
Just a comment. Last night I was out at Mount Pleasant and we had a homeschool group out there. So I was talking to a little girl and her mum about our first female astronaut in Australia, and her eyes lit up. And her mum said, "Do you want to be an astronaut?" And she said, "Yeah, I'd like to be an astronaut, Mum, and go to the moon and maybe even go to Mars." So those little kids are so like sponges, and they just absorb everything you tell them. And even though she mightn't end up being an astronaut, chances are she might do too.
Yeah, was she the girl in the pink beanie? Yeah. She was very, very keen.
Further questions? No? Or we might wrap it up there, Kelly.
Yep.
How'd you go for time?
I don't know. What time do we start?
Okay, 1:45. That's good.
That's all right.
So, Kelly, on behalf of everyone here, what a fascinating presentation, very inspirational. So a lot of it material we can use going forward. So on behalf of us all here, thank you very much for your presentation.
Thank you.
Thank you. And I have.
So one thing, Kelly, I just thought,
Thank you.
A little bit of Tasmania to take back.
Thank you.
dark skies, so do you talk to the kids about the dark skies?
Yes, I do.
And what we're trying to do with that?
Yeah, so one of the things that I've spoken to my principal about is that we could potentially become the first dark skies school in the world, but certainly in Victoria, and he was all for it. He likes being the first of doing anything. So one of the things that I want to work with him on is getting that, but I would love to develop we do water sustainability, we do, so all of my feeder primary schools have all got a garden. Every single one of them has got a vegetable garden. They all do composting and they all have water-wise stickers and things around the school. Why don't they all have let's turn the lights off, let's have dark skies for the environment? So I think all we need to do is write up a curriculum and then hand it off to schools that's a ready to learn, like easy to follow sort of a curriculum. The primary schools would love to take it up. And if it then means that the councils take on board some of the policies, that would be even better. So we can give it as here's what you can do in your classroom, here's what you can do as a school and as a school community, and then something to take home for the parents as well. I'm now just spinning more and more ideas in my head, so I'll write that down soon. But that was the idea. I'll ask you to write it down. But like I said, it was the idea was originally just with my principal, just to get that sort of ball rolling, and then once you've got one school, then other schools will follow. Yeah. So, we'll see. Beautiful.
Thanks, Kelly.
No worries, thank you.
I don't think I've introduced the group to Hugh up the back there as well, with Kelly's travelling partner.
So, my husband,
yeah.
He looks tough and carries my stuff.
Yeah, so welcome to Hugh. So we're going to have a break now. So I think, for the rest of the evening, we'll just use the opportunity to have a chat and perhaps, come and ask Kelly some more questions about citizen science.
Happy to give anyone any of the documents or anything that I've got, so if you want it, please have it.
And if you haven't filled out a Lucky Door prize, please do so. All right.
Thank you.
So in the live stream, being in the US.
Yeah, okay, yeah. Yeah, okay, yeah.